Given a non-empty array of integers, nums, every element appears twice except for one. Find that single one. Follow-up. Could you implement a solution with linear runtime complexity and without using extra memory? I can't, but I'm pretty sure somebody else can, and will let me know in the comments. So we have nums, which is 2, 2, 1. The single one that appears is this 1, which is the output. The single one that appears is this 4, which is the output. And then we have just a single character, and that's the output. Every element appears twice except for one, which only appears once. Similar topics, related questions. So yeah, not super familiar with bit manipulation, but I am familiar with hash tables. So we could use that as one of our approaches. The first thing, typically with arrays, a lot of the times you can come up with a solution by either sorting or using a hash table. So we'll come up with two solutions, one with sorting and a hash table. We should, if we sort it, we should be able to sort the array, then iterate linearly, linear, I can't spell. Then we'll just do let's say, then do a linear iteration through the array. And then all we have to do is check the previous and next element that they don't match our current element. So if we do something like this, or this is probably a better example, since we have these, we can do this, which when we sort it, we'll have 1, 1, 2, 2, and then 4. And then as we do our pass, when we start off here, right, we'll say, okay, well, this matches our next element, so this isn't valid, so we can move this forward. This matches our previous element, so this doesn't matter, we can move forward. And then the same thing with this, we can look ahead and say, okay, this matches, so this doesn't count, we can move forward. And then we can say, all right, this matches our previous element, so this isn't valid, we can move forward. And then when we hit this last one, we could say, okay, this doesn't match our previous element, and our next element is technically undefined, but that's also doesn't match 4. So this is how we can return our result. So the time complexity will be O of n log n, and then the space complexity will be, I'll say O of n, because I don't know of any sorting algorithm that you can do better space. So even though we're not using an extra array or anything, just the sorting, I mean, worst case, we're gonna have to use some sort of recursion. So we can sort it, A, B, A minus B, which is just gonna sort it in descending order, like we have it below. And then we should iterate through the list of the array, and then check our previous element, which would be check if nums of I minus 1 doesn't match our current element, and nums of I plus 1 doesn't match our current element, then return nums of I. And I believe that should work. The only thing we might have to check as a corner case is if there's a single element here, which I guess all we would have to do is check if the length is 1 or less than 1, and just return the element. But let's see. Yeah, so this is fine. So they passed anyways. So a follow-up, I guess, would be, all right, what if we want to do better time complexity? We would have to use basically the same space, but yeah, we would increase our time complexity by just using a hash table, but instead of using it as a typical hash table to store just any random element, we can use it as a frequency counter. So frequency, we'll call it a frequency table, which is basically going to iterate over the array, and then for each of these elements, we're just going to check. So like given the same array, as we iterate over, all we're gonna do is hit this first element. So we'll have 0, 1, 2, 3, 4, and this will be our index. And then this is going to be our elements. And then, so when we're here at index 0, we're going to say, all right, we've seen 4 one time. So we'll just record that. And then at index 1, we'll say, okay, we've seen 1 one time. So let's just record that. 2, we've seen 2 one times. So let's just record that. And then 1, we've seen twice now. So we'll update that. And then we can move this over and then say, okay, 2, we've seen twice. So now that we have this frequency table, I'll just call it freak. Now that we have this frequency table, we can just iterate over it. And then when we see the element that's only appeared once, we can return that. So we'll just set our time and space complexity. We're going to be linear. And so if we just wanted to implement that, should actually, so we'll have our frequency, which we can use the reduce function to count how many times we've seen an element. So we have our accumulator and then our current element. And then we'll return our accumulator, and then our accumulator current equals accumulator current or 0. And then increment by 1. And now we can just iterate for the key in our frequency table and check if frequency key is 1, then we can return that key. And then if we submit, very cool. So those are the 2 implementations. I understand you could probably do like some sort of bit manipulation stuff, but for a more optimized approach, but I'm not familiar with that. And I only really know JavaScript as a programming language. So I don't know, crucify me in the comments or something. But like, comment, subscribe, and I'll see you in the next video.